Hello, welcome back to Metal Machine Shop. This time we're going to have a go at milling some cams for my miniature engines. I've already had a go, but I'm not really very happy with the results, so I'm going to try a different approach. This is the engine here, just so you have a slightly closer look at it. This is the inlet cam and the exhaust cam. So let's take you through the setup here. This is a wooden copy of one of the cams. This is 5 times the scale. What I've done is measured that to get the offsets. This is the inlet cam in this case. I've calculated the offsets and written them down on this piece of paper, or rather typed them. So for the angles of rotation, those are the offsets in millimetres that we need to achieve for each 10 degrees or so of cam rotation. I've got the rotary table set up on the milling machine here. What I've got is a chuck adapter. There's the 3-jaw chuck that has come straight from the Myford lathe. This bit of iron, steel, not quite sure what grade it is, but hopefully a case hardening grade. I've already turned down to a constant diameter on the lathe, and it's supported on the outer end with the tailstock here. I've set up the rotary table square to the milling table edge using an engineer's square, and I've secured it using a number of dogs here just to stop it slipping around. Go around to this side, you can see where it's been secured at the front. And on the side of the rotary table we've got the protractor dial here, so I'm just simply going to be using that to set the angle. That's the locking handle just up here, and we rotate the table using that handle at the front. I've already checked that that's horizontal using a dial test indicator, and there is little to no run out on the chuck. I've checked that as well using a dial test indicator, so the workpiece is running true. Here I've decided to use a fly cutter for this job. It's one of my favourite milling tools. The reason for that is it's very easy to sharpen the single tool bit. Also with this particular one, which is homemade by the way, it gave me the clearance I need over the chuck. Right, this is my digital readout that I'm going to be using for this job. The first job that I need to do is to bring the bottom edge of the cutting tool right down to bang on the centre line of the workpiece, so that I can then use that as the datum and the DRO to set the correct offsets. Firstly, what I'm going to do is to measure the diameter of the workpiece using a micrometer. There we go. I'm not sure whether you can see that, but the diameter is 11.58 millimetres. 11.58. I'm just going to check that at the other end of the workpiece. Have another look. That comes out at 11.585. Close enough. Let's call it 11.58. Just dividing that by 2 using a calculator because I'm too stupid to do it in my head. So the radius of that bar is 5.79 millimetres. Now I'm going to lower the cutting tool so it's just touching the top surface of the bar, and from that point I'm going to lower it a further 5.79 millimetres, which is the radius of the bar, so that the bottom of the cutting edge is bang on the central axis of the tool, of the workpiece rather. This is only going to be accurate if the cutting tool is right on the top surface of the workpiece here, so I'm going to use the old engineer's trick of a ruler. Adjust the cross slide until that ruler comes to the horizontal. I'm just doing this by eye, that'll be accurate enough. So I now know that the cutting tool is positioned accurately right over the highest point of the workpiece. Now I'm just inserting the feeler gauge between the cutting tool and the workpiece and lowering the head of the milling machine until I can just feel the cutting tool starting to grip the feeler gauge. So at that point I know that the cutting tool is precisely the thickness of the feeler gauge above the top surface of the workpiece, so I need to lower it by 0.1 millimetres to get it just touching the workpiece. Here goes. So at that point I'm going to zero the z-axis again. There we go. And I'm now going to lower the head of the milling machine half of the diameter of the bar. Got a visitor, look. Hello cat, you going to come in? No. It's Bit of a miserable cut, that one. Anyway, it's distracting me from my work. There we go, 5.79, spot on. So at that point, I'm going to zero the z-axis one final time. And we now know that the cutting tool is positioned precisely over the central axis of the work. So it's time to start machining. What I'm going to do is going to start with the highest point on the cam, which is the nose of the cam, where the offset is 5.30 millimeters. That's at the 180 degrees position, and I'm going to work back from there. So these, from about here to here, is the base circle of the cam, so that's effectively a circular radius, and then the cam, the sides and the nose are angled accordingly. So I'm going to rotate the rotary axis to the 180 degrees position. There we are, and I'm just going to lock it using that one and the other handle the other side. I'm now going to raise the milling head again to bring the cutter up. I'm not going to go to the full depth of cut on the first pass. I'm going to go a bit higher and just come down to the 5.3 millimeters in a number of separate bites. There we go, it's time to start cutting. I'm going to take a light pass and see how it goes from there. I've just taken a light witness cut along the top there, but it occurs to me that I need to take some steps to stop the cutting tool crashing into the chuck there. So what I'm going to do is set the stops on the mill table. I'm just going to set that stop on the left. So I've now turned a flat on the top of the bar, and I'm going to keep taking further cuts until I'm down to full depth. So I've now come down to the full depth of 5.3 millimeters, which is right on the top of the cam nose. I'm now going to bring the milling machine head down to the next measurement and rotate the chuck 5 degrees for the next cut to start to form the shape of the cam. So that's the next cut done. I'm now going to do the same thing, rotate the rotary table another 5 degrees, lower the machine head by another small amount in accordance with my table, and repeat. I'm now going to repeat this over and over again until half of the cam profile is formed. Well, I've got round to the 180 degrees mark and all's going well so far, so I'm going to go back up the other side and back up to 0 degrees and to the nose of the cam. I'm not sure if this is going to show up on the camera, but basically we're forming the cam by a series of small facets, which later I'm going to file smooth or sand smooth with emery cloth. So I've finished the milling. Now I'm going to transfer this back to the lathe to do some turning operations. There we go. Now over to the trusty Myford, and I'm going to screw it onto the spindle nose. I've now parted off the individual cams and drilled them through, and they're all now ready to have the facets polished off. Thank you for watching, and please subscribe for more videos like this one. See you next time.